Hello and welcome to Studying with Chris, where I try my best to explain topics to help both you and me understand concepts. Today we'll be going over solving radical equations. To begin with, when we solve radical equations, we have something known as roots. These are basically the solutions for our equations. So for example, if we have, say, 2 root x is equal to 3 minus, say, root 2x. Our root is basically the value of x, all right? So in radical equations, we have 3 types of solutions. One is known as our real roots. So real roots are solutions to our answers that satisfy our restrictions for our variable. So when we define what our variable can be, it satisfies that restriction. And when we plug it back into our original equation, it satisfies the equation as well. So it satisfies both our restriction and equation. Now, non-real roots are solutions that may satisfy the restriction. So most of the time they will satisfy the restriction. However, if you plug that number back into the original equation, you won't get the right answer. So it won't satisfy the original equation. Now, an extraneous root is kind of like a subset of non-real roots, where they are technically not real solutions. However, they're more just external solutions. So extraneous roots can be also known as external roots, where the answer to it satisfies the equation outside of the realm of radicals. So we'll go over an example later that can show you what I mean. But for extraneous roots, basically, it won't satisfy the restriction. And when you plug it back in, it won't satisfy the equation either. Now, we're going to go through a few practice examples to see what I mean. Alright, let's give this question a shot. If you'd like to try it on your own, feel free to pause the video. Otherwise, we'll get started. So, before everything, let's define our variable. So we know that the value inside our radical has to be greater than or equal to 0. So we write 3x plus 1 has to be greater than or equal to 0. Now we isolate for x, so we subtract 1, 3x has to be greater than or equal to negative 1 divided by 3. X has to be greater than or equal to negative 1 over 3, such that x belongs to real. And we'll box that out. Right, now we know the restrictions we set on x, so we can start by solving it now. So we have a square root of 3x plus 1, and we need to get rid of our square root to make it easier to isolate for x. So to do that, we'll square both sides since it's the inverse operation of square root. So we have 3x plus 1 is equal to 25. Now we'll subtract 1 for both sides. So we have 3x is equal to 24. Divide both sides by 3. X is equal to 8. Now before we box that out, let's substitute it back into our original equation of root 3x plus 1 equals to 5. And let's see if that satisfies the equation. So 3 times 8 plus 1 equals to 5. Here, 3 times 8 is equal to 24. 24 plus 1 is 25, so we have root 25 is equal to 5. And that checks out since we're taking the principal square root. So we know that x is equal to 8 is a valid answer, so we'll say, therefore, x equals to 8 is a real solution. we go. Alright, let's give this one a shot. If you'd like to try it on your own, feel free to pause the video. Otherwise, we'll start now. So, once again, let's define our variable. So we know that 7 minus 3x has to be greater than or equal to 0. Now there's two ways to define our variable, so we'll move over here. I'll do another one here, minus 3x to be greater than or equal to 0. Both ways will get you the same answer, so let's start here. So we see that we have a positive 7 and negative 3 times x, so we'll add the 3x to the other side. So that we'll have 7 is greater than or equal to 3x divided by 3 to isolate for x. So we have x is less than or equal to 7 over 3, such that x belongs to real. Now this is probably the easier way to do it. However, over here, say we want to keep 3x on this side, so we'll subtract 7, we have negative 3x has to be greater than or equal to negative 7. Now, just a note for inequalities, if you ever divide or multiply by a negative number, you have to make sure to switch the signs of your inequality. So, for example, if I divide by negative 3, I need to switch the sign here to the other way now. So we'd have x, and these two negatives cancel out. X is less than 7 over 3. X belongs to real. So as you can see, these two answers are the same. So just one note if you're looking for the restriction, that if you multiply or divide by a negative number, you have to switch the sign of your inequality. All right, now that we've defined the variable, let's get back to here. So just like before, let's square both sides to get rid of our root. So we have 7 minus 3x is equal to 100. Let's subtract by 7, so it's minus 7, minus 7. We have negative 3x is equal to 93. Let's divide by negative 3. We'll have x is equal to negative 31. Awesome. So let's see if it fits our restriction. So negative 31 is less than 7 over 3 since it's a negative and 7 over 3 is positive. Now let's see if it fits back into our original equation. So we have root 7 minus 3 times negative 31 is equal to 10. Right? So let's go through. Let's see. 3 times negative 31 is negative 93. So we have root 7 minus negative 93 is equal to 10. Now, since we're subtracting a negative, it's basically just adding. So it's basically 7 plus 93. So that's root 100 is equal to 10. Since we're taking the principal square root, that checks out. All right? So we know that x equals to negative 31 is a possible solution. So we can say, therefore, x equals to negative 31 is a real solution. Alright, this one is a special case, so if you'd like to try it on your own and see what you get, feel free to pause the video. Otherwise, I'll start now. So, we have root 2x plus 5 is equal to negative 3. Right off the bat, we can tell that something is wrong. So since we're still under the context of radical equations, we know that if you have a root of any value that has a even index, we know that we have to take the principal square root. Now, the principal square root just means the positive value if there is both a positive and negative possible value. So we know that if we have a square root of a value inside, we know that whatever the answer is, it has to be positive. So right off the bat, we know something's off here since we have negative 3 as our answer. Now, let's try to solve this regardless to see what we get. So beforehand, let's find out the definition for a variable. So we have 2x plus 5, has to be greater than or equal to 0. Let's isolate for x, so we have 2x be greater than or equal to minus 5. Divide both sides by 2. X has to be greater than or equal to negative 5 over 2. X belongs to real. Let's box that out. There you go. So now let's try solving it. So we'll square both sides. Once again, you can see where a problem kind of arises, since we know that negative 3 squared will equal to 9. However, square root of 9 in the context of radicals will not equal to negative 3. So this is kind of a problem that will arise in the context of radicals. However, once you go outside of radicals, you don't really need to worry about this too much. So regardless, we'll try solving it. So 2x plus 5 will equal to 9. Let's isolate for x, so minus 5, minus 5. 2x is equal to 4. Divide both sides by 2. X is equal to 2. Now x fits our restriction of being greater than negative 5 over 2, since x is positive. So let's try substituting it back into our equation to see what we get. So we have root 2x plus 5 is equal to negative 3. Substitute it in, so we have root 2 times 2 plus 5 is equal to negative 3. 2 times 2 is 4. 4 plus 5 is root 9. Root 9 is equal to negative 3. Root 9 is equal to 3. So we have 3 is equal to negative 3. Now this is not correct, since we know we have to take the principal square root, so this would not satisfy the equation. So usually if you see a root with an even index is equal to a negative number, right away you can kind of conclude that there are no real solutions. Since we are in the context of radicals. Sometimes the questions may throw you off if they have a root of a value plus another value, in which you have to isolate to have the root equals a constant. And if it equals the constant and the constant happens to be negative, you can kind of infer that there are no real solutions. However, if you want to go through with it and solve it to plug it back in to see if it satisfies the equation, by all means go for it if it helps you understand. But otherwise, this is just a quick shortcut to see if it's equal to a negative, this can't exist in radicals. So how would we write this out? We just say, therefore, there are no real solutions. There we go. Alright, this one's just another format to radical equations that you may see. So if you'd like to give it a go, feel free to pause the video, otherwise we'll begin now. So once again, let's start by defining our variable. So we see that x is in a square root by itself. So what would we do? We just simply say that whatever the values in here has to be greater than or equal to 0. Since x is the only value, we can just say x has to be greater than or equal to 0, such that x belongs to real. And from here, we can just simply solve it to isolate the radical. As you can see here, we have a negative 4 root x and a negative 3 root x. So if we want to bring one of them over, I'll bring the 4 over just to make it easier. So we'll plus 4 root x plus 4 root x, so that we have 3 equals to 2. Now 4 plus negative 3 is just 1, so it'd be 2 plus root x. Now let's subtract 2 from this side. So we have 1 is equal to root x. Square both sides. We'll have x is equal to 1. Now, let's see if it fits our restriction. 1 is in fact greater than 0, so that satisfies our restriction. Let's plug it back into our original equation to see if it's correct. So 3 minus 4 root 1 is equal to 2 minus 3 root 1. Now, root 1 is just the same as 1, so it's basically the same as 4 times 1. So we can simplify this to 3 minus 4 equals to 2 minus 3, since this is the same case over here. 3 minus 4 is equal to negative 1. 2 minus 3 is also equal to negative 1, so that checks out. So this is a real solution, so we can write this as therefore x equal to 1 is a real solution. Right, this next one's a bit unique and it might be a bit long, and there are also multiple ways to solve it. So if you'd like to go ahead and try it on your own, go for it. Otherwise, I'll start now. So once again, for everything, let's solve for our restriction. So we have 3x minus 1 has to be greater than or equal to 0. We can add 1 to both sides, so we have 3x has to be greater than or equal to 1. Divide by 3 both sides. X has to be greater than or equal to 1 over 3, such that x belongs to real. And we can box this out. There we go. Now, there are multiple ways to solve it. However, the first step for all of them are the same. So, as you can see, we have a coefficient, a radical, and a constant. So, we wouldn't want to square this now, since we'd have a radical and a constant, and they'd have to be multiplied to each other, and that's kind of a pain to deal with. So instead, we'll just subtract our constant to the other side. So we have 1 over 2 root 3x minus 1 is equal to 13. Now from here, there are different ways to solve it. I will show 2 ways that are possible to solve, and we'll see what we can do from there. So one way might be a bit longer, but it might help with your understanding more, and another way is kind of just a shortcut. I'll start with the longer one first. So say if you have a coefficient here, and if your coefficient doesn't go with your answer on the right side very well, then you might want to try this method. So for instance, let's just start from here. Say we square both sides. So we have 1 over 4 times 3x minus 1 is equal to 169. Now, in this case, a common mistake that myself included I have made are not distributing the coefficient. So for instance, one mistake that I usually make is I simplify this to 3 over 4 minus 1, 3 over 4x minus 1, when in reality, whenever you have a coefficient times a radical and you square it, your coefficient has to multiply to every term inside the radicand. So in reality, this would be 3 over 4x minus 1 over 4. Now since we have a fraction as our coefficient, this isn't the ideal way to simplify it. However, if you had a whole number or just any number in the coefficient and you wanted to square it with the radical, then you'd have to make sure you're distributing it properly. However, this, like I said before, this method's kind of long, so we'll do the second shortcut. So as you can see, we have 1 over 4 times 3x minus 1 is equal to 169. So we can simplify this just by multiplying both sides by 4. So this times 4 times 4 will have 3x minus 1 is equal to 676. Let's simplify this by adding 1 to both sides. So we'll have 3x is equal to 677 divided by 3. We'll have x is equal to 677 over 3. And if you could simplify it, you could, but in this case, we can't reduce it any further. So we just have x is equal to 677 over 3. Let's check to see if it fits our restriction. 677 over 3 is greater than 1 over 3, so it satisfies that. And let's plug it back into our equation to see what we get. So we have 1 over 2 root 3, 677 over 3 minus 1 is plus 14 is equal to 27. Alright, so 3 times 677 is, 3 times 677 over 3 is 677. So we have 677 minus 1 over 2 plus 14 equals to 27. 677 minus 1 is 676. Square root of 676 is equal to, let's see, I believe that's 26. So we have 1 over 2 equals times 26 plus 14 equals to 27. Now half of 26 is 13. 13 plus 14 is equal to 27. And if you check that, that checks out. So it means 677 over 3 is a valid answer. Now, before we box this out, let me show you the other way to do this. Now, the second way may not always work since your coefficient may not go into your terms very easily. So, for example, if here we subtract 14 from both sides, so we have 1 over 2 root 3x minus 1 is equal to 13. We have our fraction here, so we could technically get rid of this right away, so times 2 times 2. So we'd have root 3x minus 1 is equal to 26. This is technically a way you could do it. However, for example, if our equation changed a little to where it would say, let's say it's 2 root 3x minus 1 is equal to 13. If we divide by 2, and then we solved it from here, it would still technically be correct. However, just dealing with fractions and radicals is very difficult. Not very difficult, but it's more of a hassle than it might need to be, so it wouldn't be ideal. However, if you are in a situation where you think you could do it, then it would definitely help. So let's try to solve it just to see what answer we get as well. So this equals to 13 times both sides by 2. We have root 3x minus 1 is equal to 26. Square both sides. So we have 3x minus 1 is equal to 676. Add 1 to both sides. We have 3x is equal to 677. Divide both sides by 3. We have x is equal to 677 over 3. And we got this answer before, so we know this checks out. So, since we know it works, we can say, therefore, x is equal to 677 over 3 is a real solution. Now, in most cases, you'd leave your answer as a fraction since you'd want it to the exact value. However, if it asks you to round, then you just plug it into your calculator and round. Alright, this is our next problem. If you'd like to give it a shot, go ahead. Otherwise, I'll start now. So this question is a little different since we have a cube root and we usually deal with square roots. However, the way to solve it wouldn't be much different. Beforehand, let's start by defining our variable. So we know that if we ever have a root that has an even index, we can have negative numbers in the radicand, since it wouldn't really give us complex numbers or imaginaries, and we would still be able to solve it. So in this case, I wouldn't worry about needing to define x as being greater than or less than anything. We could just simply say x belongs to real. Now this would pretty much only ever be the case if you have an odd numbered index. So that's our definition. Now let's solve. So we have a cube root, so instead of squaring it to get rid of the root, we'll just cube it, and we'll cube both sides. So we have 72x is equal to 216. We divide both sides by 72. We'll have x is equal to 3. Now we can plug it back in if we really wanted to. So 3 root 72 times 3 is equal to 6. This is equal to cube root of 216, which does so happen to equal 6, so that checks out. So we can say, therefore, x equals to 3 is a real solution. There we go. All right, this will be our last practice question. This one's a little harder and it's more interesting. So if you'd like to give it a shot, feel free. Otherwise, I'll walk through it soon. So let's begin by defining our variables. So here we have two different radicands, which means we need to observe two different possible definitions for our variable. So over here we have x by itself, so we can say one of them is x greater than or equal to 0. And another one we have x plus 2, which you can isolate it, but this is just x has to be greater than or equal to negative 2. Now, we have two different definitions for our variables. However, for each radical equation, you can only have one definition for each variable. So in this case, we have to pick one of these. So which one would we pick? Well, to find that out, we need to look at a number line really quickly. So over here, say we have negative 2 and we have 0. So x is greater than or equal to 0. Remember, that's a solid dot here. X is greater than or equal to negative 2. Another solid dot here. Now, in this case, if we said that x has to be greater than or equal to negative 2, we would have this gray area here. Now this area here is kind of tricky because that basically means that between negative 2 and 0, there are possible values of x. However, we know this can't work for our equation since we have one variable that has to be greater than or equal to 0. So, for instance, if we took x has to be greater than or equal to negative 2, let's say x is equal to negative 1, this one would be fine since we'd have a square root of 1. However, we'd have square root of negative 1 here. And since we're not dealing with complex numbers right now, we couldn't put imaginaries. So this wouldn't satisfy our restriction, and it just wouldn't work in the context of radicals right now. So we need to pick a definition that satisfies all values for both of the radicals. So in this case, we'd say we'd pick x is greater than or equal to 0, since there are values that would fit both of these equations and there isn't any gray area. So, like I mentioned before, we'd pick x is greater than or equal to 0, and we can also say x belongs to real. Alright, let's clear this up and let's start solving. So, we know that x has to be greater than or equal to 0, and let's just start by solving. So once again, we need to get rid of both of our roots, so we'll square them both. So we'd have 64 times x plus 2 is equal to 9x. Now, just like we mentioned before, make sure you're using distributive property correctly on both of these terms. So we'd simplify this to 64x plus 128 equals to 9x. Now let's subtract 64x to isolate our variable. So we'd have 128 is equal to negative 55x. Now let's divide by negative 55. So we'll have x is equal to negative 128 over 55. Now, let's take a look at our restriction quickly. Turns out this does not satisfy our restriction, since we have a negative value and we know that x has to be greater than or equal to 0. So we know that this doesn't satisfy our restriction. However, if we know it doesn't satisfy our restriction, we know it wouldn't fit our original equation. However, if we took a look at our kind of like derived equation, if you would. So let's see, 64 negative 128 over 55 plus 2 equals to 9 times negative 128 over 55. So if we wanted to check this, we could say 64 times negative 120 divided by 55. And 9 times 128 divided by 55. You would find out that these, in fact, do equal each other. So this is known as our extraneous root. So it's basically a solution to an equation that satisfies the simplified version of the equation, but not our original equation. So in this case, where we only have one variable, this is known as our linear equation, right? So there's only one variable, it's just like algebra. However, this is known as our radical equation. So this solution would satisfy our linear equation and not our radical equation. So this is known as our external root. So it's kind of a solution that's not fitting within the context of radicals. So in this case, since this doesn't fit our original equation nor our restriction, we just say, therefore, x is equal to negative 128 over 55 is an extraneous solution. And we can box this out. Alright, but otherwise, that is all for me today. Thank you for tuning in and just learning how to solve radical equations. So, all in all, if you have any questions, please let me know. Otherwise, thank you for studying with me.